Math is clean, math's easy when you're doing math with Miss Lee.
Welcome to the lesson on section 2-6, Algebraic Proof. In today's lesson, we'll work toward understanding the properties of equality and writing algebraic proofs in two-column form. Follow along on pages 4 through 6 of Packet 3 as you watch and listen to this video. Press pause now if you don't have Packet 3 in front of you. In a proof, we state existing rules in a logical order to explain why a new rule is true. The columns of a two-column proof represent the statements in our argument and their reasons. Also on page 4, you should see a table listing common properties that are used in proofs. Look at the first 4 properties in the table. They should look familiar. They're the properties that allow you to add, subtract, multiply, or divide the same numbers to both sides when solving an equation. When we use these properties as reasons in our proofs, you can abbreviate them using the parts typed in bold. For example, you can write addition property instead of addition property of equality. The next 3 properties in the table on page 4 can be thought of as the RST properties because they begin with the letters R, S, and T. The reflexive property states that any amount is equal to itself. You're probably thinking right now, well, duh, I've known that my entire life. Now we're giving a name to it. You won't understand why we need a property like this until later in the year after we've done some more proofs. The symmetric property is what allows us to switch the sides of an equation. For example, you already know that 5 equals x means the same thing as x equals 5. You just didn't realize you were using the symmetric property every time you made this kind of switch. The transitive property states that if 2 amounts are both equal to a third amount, then they must be equal to each other. So here, A and C are both equal to B. This must mean that A and C are also equal to each other. Then at the bottom of the table, we have some properties that you've already seen and probably know by name. Substitution allows us to replace an amount by any amount equivalent to it. The distributive property shows us how to multiply a number by an addition or subtraction problem to eliminate the parentheses. Now turn to page 5 in your packet. On the top of page 5 is an example of an algebraic proof in which all of the statements and reasons have already been completed for you. This proof is trying to show that if 1/4 times x plus 10 equals 2, then x is equal to negative 32. Notice that the first line just states the original problem, and its reason is called given. In the second line of the proof, the statement shows that we subtract 10 from both sides of the equation to start solving for x. The name of this reason is the subtraction property. The reason in the third line is called substitution because I substituted 1/4 x plus 10 minus 10 from the previous line with an equal amount, 1/4 x. And I also substituted 2 minus 10 on the right side with its value, negative 8. In the fourth line, I multiply both sides by 4 to cancel out the 1/4. And the multiplication property is the reason I can do this. And then in the last line, I replaced 4 times 1/4 x with its value x, and replaced 4 times negative 8 with its value, negative 32. This is by substitution. Since my last statement matches what I was asked to prove, the proof is complete. In the second line of this proof, you can also use simplify as the name of the reason for how 1/4 x plus 10 minus 10 becomes 1/4 x, and how 2 minus 10 becomes negative 8, instead of calling it substitution. We can also use simplify as the name of our reason in the last line for how we changed 4 times 1/4 x into x, and 4 times negative 8 into negative 32. This proof is shown about halfway down page 5 in your packet. Sometimes we may combine the substitution or simplify step with the addition, subtraction, multiplication, or division properties. Notice in this version of the same proof, which is much shorter, when 10 was subtracted from both sides, I just wrote 1/4 x plus 10 becomes 1/4 x, and 2 becomes -8. Then in the last step, I'm still multiplying both sides by 4, but I skip right to showing that that gives me x on the left side and -32 on the right side. When you write your own proofs, you may choose to write your proof using either method shown on the top of page 5 or in the middle of page 5, where you show the substitution and simplify steps or you skip over them. However, if you're asked to fill in the blanks in a proof that has already been partially written for you, recognize that either method can be correct. You will have to figure out which method was used based on the number of blanks that are given in the proof. Move to number 9 at the bottom of page 5. Here we're asked to fill in the missing statements and reasons. The first step should always state the given information. So that's the original problem. 3k plus 5 equals 17. Now if I compare that first line to the second line, I can see that 5 is subtracted from both sides. That's the subtraction property. By substitution, I would rewrite the left side as 3k and rewrite the right side as 12. The next thing I would do to solve for k would be to divide both sides by 3, by the division property. And then the reason that I can change the left side to k and the right side to 4 is substitution. Let's move to number 10 in the packet on the top of page 6. The first statement is the equation we're solving, so that reason is given. Then the distributive property is used to multiply the -3 by x plus 2. And I can see when I compare the second and third lines that x is being added to both sides. That's the addition property. And then substituting on the left side, -3x minus 6 plus x is -2x minus 6. And on the right, 16 minus x plus x is 16. In the line underneath that, I can see that 6 is added to both sides, so that's the addition property. And again, substituting, the left side can change to -2x, and the right side can change to a 22. The next thing I would do is divide both sides by -2. That's the division property. And then changing the left side to x and the right side to -11 is substitution. Number 11 at the bottom of the page is an example of a proof that begins to use some geometry. In this proof, we're asked to prove that if segment AB is congruent to segment CD, then x equals 2. The given information is that segment AB is congruent to segment CD. In the second line, notice this step. By the definition of congruent segments, this means that the distance from A to B, which is AB without a symbol over it, is equal to the distance from C to D, which is CD without a symbol over it. Then, substituting from the diagram, I can replace AB with 6 minus x and replace CD with 3x minus 2. In the next step, it looks like the x was added to both sides, so that's the addition property. The next thing I would do to solve is I would add 2 to both sides. So I'm showing that, and the result of adding 2 to both sides, the 6 becomes 8, the 4x minus 2 becomes 4x. Notice there's no room in between for a substitution line here, so I'm just writing the result of the addition. And then in the next line, it looks like both sides were divided by 4, so that's the division property. And then the symmetric property is what allows me to switch the left and right hand sides of the equation. So the statement there must be x equals 2 instead of 2 equals x. And that's what I'm trying to prove. This concludes our lesson on section 2-6 algebraic proofs. Now you're ready to try assignment 1H.